right, so this is Module 6, Lesson 9, Concept Development. We're going back to our template that we were using earlier. Now, this time, we're going to come up to our box at the top, and we are going to make a line L. And we're going to use the rule, y is 2 more than x. So, when x is 1, what is the y coordinate if I apply the rule? So if y is 2 more than x, so this is 2 more, 1 plus 2 is 3, right? All right. So the rule says y is 2 more than x. So if x is 1, y must be 3 because 3 is 2 more than 1. I just added 2 to 1 and got 3 as the y coordinate. So what I want you to do is I want you to go through and complete the chart, and then I want you to plot the points and connect the line. Go ahead and do that and come on back. All right, so did you end up with 1, 3, 5, 7, 10, 12, 15, 17? I plotted my points and I drew my line and I labeled it line L. All right. How did you do on that? Give yourself a pat on the back if you did well. Now, I want you to repeat the sequence that we just did for line M. The rule is y is 5 more than x. So y is 5 more than x. So what are we going to do? We're going to add 5 to x to get our y variable, get our y coordinate, and then we're going to create our coordinate pairs. You're going to plot the points and connect the line. You might want to do it in another color just because we have these two lines here. So go ahead and do that and come on. All right. Did you get 0 and 5, 5, 10, 10, 15, 15, 20? Did you plot your points and connect your points into a line and label it M? All right. Look at lines L and M. Do they intersect? So do they cross each other? No, they don't. What is the name we give to lines that do not intersect? What do we call these two lines? We call them parallel. So compare and contrast lines L and M. What do you notice about each line? Well, to begin with, they're parallel. So they look like they are going up at the same angle. They look like copies of the same line, except M is farther up than line L. Correct? So when you say the line M is farther up than line L, farther up from what? Well, it looks like we can take line L and shift it up a bit to get the other one, right? Each point is a little higher on the points on line L. The rule for line M is to add 5 to each x coordinate. So it makes sense that the line will be higher up than line L because line L's rule is only to add 2. All of the y coordinates on M are 3 units above all of the y coordinates on line L. So with the same x coordinates, like they have the same x coordinates, but this one, it goes up by 2. This one, it goes up by 5. So compare the rules for lines L and M. What do you notice? Well, both rules are adding to the x coordinate. One rule had us add 2 to the x coordinate, and the other had us add 5 to the x coordinate. We are adding 3 more to the x coordinate in M than we are to L. That's why all of the y's are 3 more than the y's on L. Yes, yes? All right. So what if y is 8 more than x? Think about that for a second. So y is 8 more than x. Well, what do you notice? Well, it's another addition rule. We are still adding, but this time we have added 8 to the x coordinate. And the rule for this line adds 6 more to x than L, and 3 more to x than line M. So let's make a prediction. What will it look like if we draw line N? So this would be N. What would it look like if we drew line N on this page? So a prediction might be another parallel line. So you might say that I think that line L will be above the other two lines in the same plane. It might make another parallel line, correct? Because we're still adding, and instead of 2 more, 5 more, it's 8 more. So it's just going to be a little bit higher up in the coordinate plane. So now I want you to go through, just like we did over here, I want you to use the same x coordinates, but I want you to add 8 more. I want you to plot these points, and I want you to connect them and label it N. Go ahead and do that and come on back. So, did you end up with 0, 8, 5, 13, 10, 18, 15, 23? Did you plot your points and connect your line and label it N? Excellent. So we're still adding. But this time we added 8 to the x coordinate, and the rule for this line adds 6 more to the x than line L and 3 more to the x on line M. So it made another parallel line, right? So line N is parallel to the other two lines. So if you were predicting that, you were absolutely correct because it's addition rule. We have the same x coordinates and we're just adding. All right. As you can see, line N, whose rule is y is 8 more than x, creates another parallel line. Now, just thinking about it, you don't have to do it unless you want to. What would the line for the rule y is 10 more than x look like? So if it was 10 more, what do you think it would look like? Well, the line for rule y is 10 more than x would be parallel again, and its y coordinates would be greater than those for the same coordinates on the other lines, correct? It would just start at 10 and then go to 20 and then 10 and then 15 and then 20 and then 25, right? All right, so let's turn the page over and let's go to line P and line Q. Now this time, y is x times 2, and here y is x times 3. So if x is 2, what is the y coordinate if I apply the rule? Well, it's y is 2 times x, y is x times 2. X times 2 is 4, right? So it would be 2 and 4. Now, what if I say, now before we had 0, 5, 10, 15. What if we go to, let's go back, let's go above and go 0. And what's 0 times 2? What is 0 times 2? Well, it's 0. So where would you be starting at? You would be starting at the origin, correct? Now, let's go 2, 4, 6, 8. Now, what I want you to do is I want you to apply the rule, find the y coordinate, list your coordinate pairs, plot the points, and connect the lines. Come on back when you're done. All right. Did you end up with 0, 0, 2, 4, 4, 8, 6, 12, 8, 16? Did you start at the origin and plot your points, connect your points, and label and create a line and label it P? Awesome. All right. Our next rule is going to wait for just 1 second though. Let's just say, so y is x times 2. So if x is 2, y must be 4 because 2 times 2 is 4. I just multiplied 2 times 2 and got 4 for the y coordinate. Now, we chose some new x coordinates and found our coordinate, our y coordinate, and then our coordinate pair. And we plotted it and connected the points, correct? All right, let's do the same thing, but let's do that for line Q. So compare and contrast the rules for P and Q. So how are they similar? So y is x times 2, but this is times 3, right? They are both multiplication rules. They're a little different because P is multiplied by 2 and P is multiplied by 2 and Q is multiplied by 3. So let's go ahead and start with 0, 0 up here. And then let's use the same numbers as this one. 2, 4, 6, 8. All right. You are to go through, find your y coordinate, find your coordinate pair, plot the points, connect the line, and label it, line Q. Okay, so let's compare and contrast the rules for line P and Q. One more time. They're both multiplication, and this is 2 times, and this is 3 times, right? All right. Do lines P and Q intersect? At what location do they intersect? Yes, they intersect at the origin. They intersect at point 0, 0. Now, what do you notice about their steepness? This line P goes up, increases by a times 2, like twice as fast. And line Q increases 3 times as fast, right? So they both seem to start at the origin, but then line Q starts going up really quickly. It's steeper than line P. Line P goes up more gradually than line Q. Line P is not as steep because this goes up at a rate 2 times and this goes up at a rate of 3 times. All right, so you notice that line Q is steeper than line P. The rules, look again at the rules for these lines and at the coordinate pairs that you generated for each line. So line Q is steeper because it goes up 3 times faster. So we used all the same values for the x coordinates, but we multiplied them by different numbers to get the y coordinate. I think line Q is steeper because we tripled the x coordinate rather than doubling the x coordinate. So the y coordinate gets higher faster when you triple it. Now, I have line R. Y is x times 5. So here's another multiplication rule. We're still multiplying, but this time we have to quintuple the x coordinate. So what do you think our line R is going to look like on this plane? So go ahead and we're going to use 0, and we're going to use 2, 4, 6, 8 again. And you're going to use this rule, figure out what your coordinate pairs are, plot it, draw the line, and then I want you to try to say, for instance, line R went up, it increased 2 times as fast, and line Q increased 3 times as fast. Go ahead and complete the chart and make your line and try to make that correlation or that relationship. So, question, do these lines intersect? Yes, they do. They intersect at the origin. What is the point of the origin? 0, 0. Now, so if you noticed, R is even steeper than lines P and Q. Notice that you only got to plot 3 points before it already shot off the chart. As you can see, line R, whose rule is y is 5 times, is x 5 times, rule is y is x times 5, passes through the origin and is even steeper than the other lines we've drawn. So the rule for line R is y is x times 5. What would it even look like if we decided to add in line S and we went times 6? What sort of multiplication rule could we use to produce a line that was steep, not as steep as P? So what would we do if we wanted a line that was not as steep? So it was more gradual. It didn't shoot up right away, but it was a little bit more gradual. Well, maybe we'd go back to the adding, right? Or we would need to multiply it by something less than 2, which would be 1, correct? That's how you would have to do something more gradually. All right, this ends the concept development for Module 6, Lesson 9. Your task now is to go through and do the problem set. You're going to follow along just like we did during concept development. And then the homework is on the back. All right. Thank you so much.